All right, howdy folks. Today we are going to be covering the area of parallelograms. Before we get into that, you have a warm-up to do, just one problem. So if a square has an area of 252 square centimeters, determine the perimeter of the square. All right, so that's your warm-up. Don't not do it. And I will give you a second to pause and try out that problem. All right, I'm assuming you paused. Did you pause? Did you do the problem? All right, cool. Let's get into it. So just go over this problem real quick. We have a square. That's not a square. That's not a square. This is a square. All right. The area is 252 degrees. 252 square centimeters. And so that would mean that the side length of this square is the square root of 252. All right, so I'm going to take my calculator, my handy dandy calculator, and take the square root of 252. Comes out with a weird wacky decimal. We were not told to round, so it looks like we're going to need an exact answer. So let's take this root 252 and just check 252 and to see what perfect squares we can divide out of 252. So I'll start with 4, and that worked out nicely. So I've got now a root 4 and a root 63, and then I know that 63 will divide into 9 and 7 very nicely. So I can break down my roots into root 4, root 9, and root 7. Simplify those to 2 and 3, root 7 stays the same, and that means that a single side length is equal to 6 root 7, right? 2 times 3 times root 7, 6 root 7. And so because we know that the side lengths of the square are all congruent, our perimeter is going to be 4 6 root 7s, and our total perimeter is 24 root 7. Final answer, shablam. All right, let's come on down and talk about the area of parallelograms. All right. First, I am going to point out something that we should remember about parallelograms is that we have opposite congruent sides, or rather congruent opposite sides. So that would mean that this side length is 10 feet and this side length is 11 feet. And if we wanted to find the perimeter, we could easily do so. That would be 11 plus 10 plus 11 plus 10, 22 plus 20, 42. Quick maths. 42 feet for our perimeter. All right, but we don't want to talk about perimeter, we want to talk about area. How do you find the area of this parallelogram? All right, to do that, we're going to have to do something a little wacky, a little visual. Essentially, whoa, look at it, right? Okay, I'll do it again. I'll bring it back. So essentially what's happening is we're taking our parallelogram and we are breaking it off and moving one section over here to the right. Right? Having done that, I hope you can sort of see the visual of what's going on here, that we really have a rectangle where one base is the same base as the parallelogram, right? And the height is the same height of the parallelogram. Right, so we got a base over here and a height over here. If I were to drag this back, right, it's the same base and height. They really have the same dimensions. And because we're not losing any of the shaded area, right, the shapes aren't getting smaller or bigger or whatever, right, we still have these two shapes making up our rectangle or our parallelogram, right, because we're not losing anything there. They're going to have the same area, right, that rectangle and our parallelogram. So to find the area of this parallelogram, well, we don't really need to be dragging this triangle over every time, but we do need to find the base and the height, because if we have the base and the height, that will give us the area of our parallelogram. Right? One thing that you might notice in our summary sheet is that the rectangle and the parallelogram have the same area formula. Right? Area is equal to base times height. And it's for that reason, because we can just move this triangle back and forth. right, let's get rid of some of this stuff though. Let's get rid of that. Really, we want to find the area of the parallelogram. This is what we need. We need the height, and we need the base. Right, now we already have the base because we know that this side on top is 10 feet. So we're good to go on base, but now we have to figure out the height. So how are we going to get that? You might ask yourself. Well, if we have that this angle is 137 degrees, right, then we can find out some of the angles in this triangle, right? One of them we know for sure. We know that there's a right angle here because we drew that altitude from, if we call this point A, right, from point A down to the bottom side, we drew an altitude. So we know that there's a right angle there. And that will tell us in our parallelogram that we have a right angle here. And so 137 minus 90 means that this angle is 47 degrees. Right, another thing that you could do to find more angles of this triangle, if I were to get rid of all that for a sec, right, recognize and remember that parallelograms have supplementary consecutive angles, right? Supplementary consecutive angles. What that means is that if we had a point B down here, right, that angle A and angle B add up to 180 degrees because the opposite sides are parallel in a parallelogram. So we have not alternate, same side interior angles, and those are going to add up to 180. So we can take 180 and subtract out 137, and if I put all this back, 180 minus 137, 43, quick maths. Right, and we see that that aligns nicely with the other 47 and the 90 degree angles that we have in our triangle. All right, but how does that help us get to the height of the parallelogram? Well, if we have one side and we have an angle in a right triangle, we can do some right triangle trigonometry. Right, so this 11 is across from the right angle, that is our hypotenuse. And then here you get to take your pick of the 43 or the 47. I'm just going to go with the 43. But, you know, it doesn't matter. You can go 47 and use a different trig function. But because we're going with the 43, this height, not h for height, not hypotenuse, but this height is opposite from our 43. So I'm going to mark that as the opposite side with the O in SOHCAHTOA, right? That's telling me that we should be using sine. We have an angle, so sine of 43 degrees is equal to the opposite height over the hypotenuse, 11. All right, so we want to solve for h. I am going to multiply both sides by 11 and reduce on the right. So h is equal to 11 times sine of 43 degrees. That's our exact answer. All right, but let's say that we want to round to the nearest tenth, right? If we're going to round to the nearest tenth, pick up my calculator, make sure I'm in degrees mode. 11 sine 43. So h is approximately equal to 7.5, and make sure that we include the units. We are using feet here, 7.5 feet. All right, and so now we're going to find the area, right? And recall from the summary sheet that area is equal to base times height. And for our area of this parallelogram, recall that the base is 10 feet. We just found that the height was approximately 7.5 feet. So multiply those together, the area is approximately 75 square feet. All right, so that is how you find the area of a parallelogram. The key to it is getting this formula, area of base times height. As soon as you have those two dimensions of your parallelogram, you are ready to rock and roll. All right, so that is the end of the notes. Just the one problem. You've got a whole bunch of problems in your Go formative. So go ahead and hop into that and, happy math, and I'll see you tomorrow.